Hello, today we are going to discuss about asynchronous and synchronous communications. First of all, we'll take a look at the transmission procedures. In order to send the data between a sender and a receiver, the data transmission requires the transmission of the useful signal and the transmission of the clock signal to deliver the useful signal. So the clock signal has three ways to go. The sender and receiver can generate clock signals internally. Clock signal can also be transmitted through a separate wire, or clock signal can be transmitted through the same wire with the useful signal. And in this third case, it would be referred as recovery of the clock signal from the useful signal. So first of all, we'll take a look at the asynchronous communications. Sender and receiver must not coordinate with each other before sending a data packet. Sender can take a break in between two communications, no matter how lengthy or short. The time duration of the voltage applied for one bit is known. For example, RS-232. So RS-232 is an asynchronous communication method that happens between the computer, CPU, and its peripheral devices. We'll take the case of a CPU being connected to a monitor under this communication method. So for the data communication, maximum voltage that can be applied using this method is 15 volts, and the maximum length of the cable can be 16 meters. Sender has nothing to send, then it lays negative voltage on the wire that corresponds to the bit value of logic 1. Sender has some data to send. It will send a start signal with a 0 bit as a start bit. As you can see it in the graph here, idle state is defined by the minus 15 voltage, so it corresponds to the bit value of logic 1. Sender has to stop sending the data, it will send a stop bit, and that is longer than the normal bits. As a standard, minimum time of a stop bit will be predefined on the sender side and the receiver sides. So the number of bits that can be transmitted in 1 second is known as bit rate. 9600, 19200, these are the bit rates of other serial communication that you can find on USBs. Even if the sender and receiver are not completely synchronized, the difference of the clock generator is so small that a byte will be transmitted successfully. And after every byte, a new synchronization occurs. So bit synchronization and word synchronization in asynchronous communications are accomplished in a single step. I'll show you an example here. So the green part on this graph refers to the idle state. So then comes the start bit, which corresponds to the bit value of logic 0. And then there is the complete byte, and then there is a stop bit, which has a longer time of applied voltage as compared to other bits. So the red rectangle shows the time at which the sampling was done on the receiver side. You can see here there's a minor difference between the clock running from the sender and the receiver, such that the receiver is going a bit towards the right. So in this way, the word synchronization is also occurred, but this would be accomplished because the sampling time would end with 1 byte, and after the start of a new byte there would be new synchronization. So this minor difference of synchronization between the clocks of receiver and the sender doesn't matter when we are talking about asynchronous communications. So synchronous communications, no local clock signal is needed here, as the sender sends the clock signal during the entire communication time. This clock signal specifies the length of the bit. It can be sent via a different cable or recovery of the clock from the useful signal if possible. The recovery of the clock signal, it's possible through various communication methods such as biphase, biphase mark, biphase Dieplus, alternative mark inversion, and so on. So the clock signal will be able to synchronize the bits only. The bit synchronization is occurred already, but the word synchronization is not occurred. Why? Because the boundaries of bytes are unknown in asynchronous communications. This can also result in disturbance on the transmission. So we need a method that could help us achieve the word synchronization. So sender and receiver knows a frame word with a specified bit pattern, and several frame words are sent at the start of the transmission to configure the transmission. Let's take an example here. If you have 511 bytes of user data to send, you would send it between two frame words, and when the receiver gets the first frame word, it would wait for 511 bytes. After that, it would look up for the next frame word. So if it doesn't find that frame word after a specific bytes, so 511 bytes, so the receiver knows that a disturbance has occurred in the last 511 bytes. So in order to avoid this, in order to avoid the resynchronization of a frame word which occurs when the same bit pattern that we used for the frame word occurred in the user data itself. In order to avoid this resynchronization, we have certain methods. So multiple checking of the frame word. The frame word is found earlier than the expected position. Receiver waits for the next three frame words to arrive with the right distance. And in this way, the data is lost, but it can be called from the sender again. Then comes bit stuffing. So frame word has a special bit pattern. For example, 0, tetra 1 and 0. So the sender side in user data, if there are more than 3 ones consecutively, the sender would add a 0. That's called stuffing. So that the user data looks different than a frame word. When the receiver receives the user data, so first data would be the special characters, the frame words, and when it sees the user data, it would find that where are 3 ones consecutively, and whenever receiver finds 3 ones, it would remove the 0 after that, and after that when it finds 4 ones, so that means that the receiver has found the frame word. Character stuffing is also done here. So character stuffing is done to distinguish between control characters and the data we need to define an escape character. For example, look at this picture here. So SYN means synchronization occurred thrice, and then there is start of transmission. So then there is data packets DA0 till DAN. That's the user data. And then there is ETX, end of transmission, and BCC, block code character. So the character stuffing would be done for STX, ETX, and BCC because they are the control characters. They control the flow of the transmission of the data that we need to send. And an escape character, a specific byte pattern, a bit pattern of a byte, would be placed before the control characters like start of transmission, end of transmission, and block code character. So the receiver knows that the coming code is a control character and it is not a user data. So coming over to the last slide of our video, I have summarized all the points of asynchronous and synchronous communication on this one single page. You would find some similarities in between asynchronous and synchronous communication and their differences. So if you still have some questions, you can ask me in the comments, and thanks for watching the video. Like, subscribe, and share. Bye.